Hello. Wait, hold on. I hope my mic is working well. Okay. So I'm going to be learning C again. This stream would be focused on the next chapter, which is about GI programming. Let me change to full screen. I want to set up my chat first. Okay. Wait. Okay. Let me just connect my chat. So I have my study notes open and the VS Code. I decided to remove the map view because it's just taking up space. Okay, let me just change to full screen. I don't know why this is lagging. Okay. Introduction to wait, yeah, we did this. Introduction to GTK. So far in this book, we have learned the basics of the C language and see how to use it to write text-only programs you run at the command line. Looking at the keywords and library functions that we have seen so far, it isn't obvious how you can create everything required for a full graphical user interface. Desktop, Windows icon, mouse pointer, and so on with them. It is entirely possible to do so in C, but to be honest, it would be incredibly long-winded and time-consuming. You would need to find the screen buffer in memory, the part of memory that represents the pixels which make up the desktop on the screen, then write new pixels to it for each window. You then have to write even more pixels to it to show where the mouse cursor is. You then have to monitor when the user moves the mouse and redraw the pointer each time. And then when the user clicks the mouse button, you have to work out where on the screen the pointer is and whether it is on top of the window and so on. Funnily enough, and that isn't how it's usually done in practice. Life is too short. Most of this functionality has already been written for you. Windowing systems like X provide most of the underlying features, and then user interface libraries provide a convenient means of creating GUI applications which work with the likes of X. All you need to do is choose a suitable interface library and use the predefined functions in it in your C program. There are lots of user interface libraries available. Some are designed to work with a particular desktop environment like Windows or Mac OS, while others are cross-platform and can work in a choice of desktop environments. The one which is used most often in the Raspberry Pi desktop included with Raspbian is called GTK, and that's the one we are going to look at in this book. GTK, formerly known as GTK Plus, is short for GIMP Toolkit. Its website, gtk.org. Can I open this? Describes it as a multi-platform toolkit for creating graphical user interfaces. It was originally written to provide the user interface elements to create the GIMP picture editing program. Okay, it has grown beyond that into a general user interface toolkit and is now one of the most widely used user interface libraries on the Linux desktop. The fundamental building blocks of the GTK projects are called widgets. Everything you see on the screen, a window, a button, label is a widget. The GTK library does all the work required in creating widgets. All you need to do is to tell it what widgets you want, where about you want to put them, and what you want to do. And GTK will manage everything else for you. To give you an idea of what manage everything else means, imagine the situation described above where you are manually creating a window by drawing pixels by writing data to the screen buffer. The user clicks on the window title bar, drags it to another place on the screen. You have to detect that the mouse has been clicked. You have to track it is being used and you have to redraw the window at each point as it moves, restoring what was underneath it as areas from where it has moved. Just tracking a window would be hundreds of lines of code, but with GTK you create a window widget with a single line of code and all that is taken care of. And all of that is taken care of you. Okay. One thing worth mentioning at this point is that there are two versions of GTK in use. The current version is GTK 3 and this is still under active development. Changes quite a bit between releases. For this reason, many people prefer to use the older version GTK2. This offers most of the same functionality, but it is stable code which doesn't change very much anymore. Some say that it is always better to use the latest and greatest version of anything, but more cautious old engineers like your author tend to prefer the older versions that has had a lot more testing and with which people have stopped fiddling about. One of the powerful features of GTK is theming. The appearance of every widget in GTK can be customized in pretty much every detail, from the color of the text to the shape of the corners on a button. This customization is completely separate from the actual coding of the GTK application. Instead, the appearance of the widget is controlled by the current theme, which is in use on the system on which GTK applications are running. All the example screenshots in this book were taken from a Raspberry Pi running on Raspberry Pi desktop environment, which uses a custom theme called Pix. Okay, so let's see first GTK program. Let's create a simple GTK program. Open your favorite text editor and write the following. Let me open this in File Explorer. And then how do I know if I have GTK or not? So how do I download this? We need to build GTK itself first. Refer to the compiling the GTK libraries section in this reference. Download the MSYS2 installer that matches your platform and follow the installation instructions. Yeah, I should have done this before stream. Like in this tutorial, they use GTK2. That's what I want to download. Well, what happened? Yeah, this will take time. I should do a Leetcode until then. I should write some notes. GTK, formerly known as GTK plus. Yeah, I should write this. Why isn't this? Okay. Short for GTK was originally written to provide user interface elements used to create GIMP picture editing program. Should write this and this. And then I should write this a simple GTK program. Okay, until this loads, let's just do some LeetCode then. My computer is going to be much slower. I was doing binary search last time. Let's continue this. Okay, search insert problem. It, given a sorted array of distinct integers and a target value, return the index of the target is found. If not, return the index where it would be if it were inserted in order. Target to 0, 1, 2, 3. Okay, think I have. So let's take the previous one and build on to that. So this was the last one. Target is 20. So if it's size 1, the first one is not it. If the first one is the target, then return 0, otherwise return 1, because it should be inserted in the next index. Then over here, I think I should return start index. So let's see, let's run this. Okay, it's taking time. Zero, 1, 2, 3, 4, 5, 6, 7. I think it should be start index. Maybe return half index. 0, 1, 2, 3, 4, 5, 6. Correct answer is 7. Let's see. Now, what happens if I do this? Okay. Then 0, 1, 2, 3, 4. Okay, well, I hope this works. Okay. 8. If do we assume that num size is more than 1? Okay. 0. If target is less than the first value, return 0. Let me see the other solutions. Yeah, I don't like this. Maybe let's do a next one. This is at 50%. Find smallest letter greater than target. You are given an array of letters that is stored in non-decreasing order and a character target. There are at least 2 different characters in letters. So C, F, J. Return the smallest character in letters that is lexicographically greater than target. If such a character does not exist, return the first character in letters. Okay, so it's CFG. CFG, the smallest character greater than C is F. Okay. So let's do this letter size, letter size, letter size, character, letter size, letter, letter A. Print letters I. Just want to see if it's done correctly. Whoops. I get mixed up with Python. What's the issue this time? Whoops. Whoops. So A, A, O, C. However, should be I plus 1. A, O, Z, Z. Alright. This works. Return the smallest character in letters that is lexicographically greater than target. Okay, so let's loop through this. If the letter is greater than target, if the letter is greater than target, then return the letter. Otherwise, return the first one. So CFJ it I don't understand. I did not recompile it. Answer is 99. Yeah, recompile again. Answer is C. Now if the target is C, then answer is F. If it's X, X, Y, Y and the target is C, returns X. Okay, now let's try to download this. Paste to okay, while this is downloading, let me do the next one. Count negative numbers in a sorted matrix. Don't have to loop through them all. So for grid size, grid column size, I is 0, I is less than grid size, I plus plus. Okay, we are going through the row number, and then we are going through the column number. Printf %d slash n grid row then column. Let's run this, see what we get. Hate, I don't understand. Why is grid column size a pointer? Okay, let's dereference it, I guess. Okay, wait. How do you do this? Let's see. How do I see the output? Oh, here's SD out, yeah. So 4, 4, 4, 3, 2, negative 1, 3, 2, 1, negative 1. Okay. Oh, why is this one written in a pointer? Can't they just use a normal int? Int sum 0. less than 0, sum. Is this, well, what are the other ways of doing this? It's just sorted array, right? Think so there's probably a faster way of doing this. I think like uh, since it's sorted, like if we encounter the first negative, we just need to count the length of the rest. So if it's less than 0, then sum, first you break out of this, and then sum is minus c. So over here, grid column size is 4. 1, 2, 3, 0, 1, 2. Yes, 1. Okay. So 1, 2, 3. 3 numbers are positive. So 4 minus 3 is 1. So you add 1. Over here, 4 minus 2 is 2. You add 2. And then 4 minus, wait, 0, 1, 2. No, I think it's just C. So 0, 1, 2, 3. So it's 4 minus 3. Let's test it now. Is this faster than what I had before? No, it's about the same. What if we start halfway and go up and down? Never mind, I guess this is good enough. So what's the progression here? No progression, it seems like. Why is it stuck here? Let me see this. Where is it stored? 64 bin. Why is the folder empty? What about the 32 one? Okay, I have no clue what's going on. Next. Find first and last position of element in sorted array. Given the array of integers, nums, sorted in non-decreasing order, find the starting and ending position of a given target value. If target is not found in the array, return -1, -1. Target 3 and 4, 0, 1, 2, 3, and then 4. Why do I need to call malloc? Integer return array, so size 2, -1, -1. Target is 8, and let's say return size is 2. I don't know why I need return size. Okay, I just want to see if this works. And 0 and 1. Pointer. Hmm. Wait, I need some revision on malloc. So memory allocate integer return memory allocate size return size. I just want to see if this gives any error. Two times size of int. I don't understand. Print f percentage d return. But why is the output like null? What if I do this? What is calloc? Yeah, I don't know. I don't know why this is not working. Unless I want to see the solution. See. This is C++. Or should I wait to do this? Ah, now it works. But like, it should be set to 2 outside of this. Like the assumption is the returner is going to be 2, right? How would they give 2 as an input? So 5, 7, 8. It's a sorted array, right? So for int I is equal to 0, I is less than nums size I plus plus, and then printf percentage d nums. Now I have another idea. Integer start index is 0, integer end index is size num size minus 1. If num size is equal to 0, return otherwise. if if uh, if num_xi uh, is equal to target, then do 3. And then do the same from the end. So I is num size as long as it's more than start index. So initially return array. The second one is equal to start index. Initially it's start index, but 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 so initially start index set to this 3. Whatever it's in the same position. Okay. Otherwise it goes from the end and goes one lower until it finds the target. Uh, yeah, I. It says start index is all the way to num size -1. Then this for loop wouldn't run. So 0, 1, 2, 3. The moment it reaches 3, this becomes true. Let's do printf. Nums I. Doesn't even reach here. Oops. Okay. Okay, let me see if there's a faster way of doing it. Okay. Uh, what about this? Does this work now? Okay, I think I will check this next stream. We'll end the stream here and then next stream I will see what's the issue. Okay then. I guess see you the next stream.